Hello everyone. The plan for today is to talk through imaginary numbers. Look at what is an imaginary number, how to add them, how to multiply them, and divide them, etc. Just looking at imaginary numbers. Notice on the screen there I have complex numbers is equal to the real and the imaginary numbers put together. The set of all complex numbers is a set of all numbers that we know, both real and imaginary. Up until now, you've probably only talked about real numbers. Numbers you can add with, you can count, you can type into your calculator and get the square root of something and it comes out to be a real number. So what happens if I try to take the square root of like a negative and my calculator says error? Well, way back when, necessity is the mother of invention, right? So way back when, someone noticed this and said, well, how do I deal with that? Clear back as far as, I think it was 50 BC, the Huron of Alexandria started looking at these things called imaginary numbers, not necessarily calling them imaginary numbers, but looking at how do I take the square root of a negative. Later, in like the 1500s, Girolamo Cardano, sorry if I said that wrong, he started looking at, well, how do I do calculations with these things called imaginary numbers or complex numbers? So that's kind of where these imaginary numbers started from, is how do we handle square roots of negatives? And from there it has evolved into complex numbers like fractals and dealing with complex equations and into electronics, and it's exploded. Okay? So this imaginary concept is a pretty big deal. So what is an imaginary number? By definition, the square root of a -1 is I. So that allows me to do things like the square root of a -36. By definition, the square root of a -1 is I. So if you remember back a while back, we did a recording on how to simplify radicals. And we noticed that we can separate those into the product of two numbers or two radicals. So I could split -36 into the square root of a -1 and the square root of 36. Well, by definition, and I keep saying that because it's important, the definition, it's just simply been defined to be this way so that we can handle square roots of negatives. By definition, the square root of a -1 is I, and the square root of 36 is 6, and typically that is written as 6i. Now, all of a sudden, I can find the square root of a negative when before I couldn't. What's the square root of a -25? Using the same logic, the square root of a -1 and the square root of 25. The square root of 25 is 5. The square root of a -1 is I. And so it's pretty straightforward. Once I understand that basic pattern, I know I take the square root of the 16, the real part, I take the square root of the negative and make it an I, and I get my answer to the square root of a negative. Hopefully you're asking this question is, well, how do I know it is really the square root of a -36? Because typically I can check that, right? Let's do one down here. What if I had the square root of a +16? Well, that's 4. Why is it 4? Why is the square root of 16 4? Well, because 4 times 4 equals 16. By definition, the square root of something is what times itself gives me 16. So then hopefully you're asking, well, then is 4i times 4i equal to -16? And if so, how does that work? Well, let's look at this. 4 times 4 is 16. I times I is I squared. How is 16i squared a -16? Should be the next question you're asking yourself. Well, I don't know. How is that? Well, let's go back to our definition. The square root of a -1 is equal to I. So if I don't know what I squared is, let's use that definition to find I squared. How is I compared to I squared? Well, it's squared. So let's square both sides. If I square both sides, I squared is I squared. The square of a square root makes it go away, and I get negative 1. So from the definition of I, using appropriate mathematical procedures or mathematical steps, I'm allowed to do the same thing to both sides. I'm allowed to square both sides and keep the inequality true. I squared must be a negative 1. So I come back down to here, and now I have 16 times a negative 1 really is a negative 16. So by definition, the square root of I is square root of negative 1 is I, and using that definition, I get that I squared is a negative 1. Memorize that. You'll use that a lot. I squared is a negative 1, and I is the square root of a negative 1. You need to know that. Okay. So how do I handle all these things? How do I add these things together? How do I subtract these things? Let's do something easy. Let's say 4 plus I plus 2 plus 3I. Now, I need to step back for a second. I just wrote that I'm going to add these two things together. But I didn't tell you what these two things represent. This is a complex number. A complex number has a real part and an imaginary part. The standard form of a complex number is written as a plus bi. My real part and my imaginary part. Please notice the careful vocabulary that's being used there. I did not say the real number and the imaginary number. It is the real part and the imaginary part of one complex number. This is one number. It is a complex number made up of two parts, a real part and an imaginary part. So if I'm adding one complex number to another complex number, 4 plus I plus 2 plus 3I, I'm simply adding two complex numbers together. How do I do that? Well, I add the real part together, and I add the imaginary part together. So the real part says 4 plus 2. The two imaginary parts are 1I plus 3 more i's gives me 4I. Try another one. 6 minus 2I plus 8 plus 5I. On all my recordings, whenever you think you can do a problem on your own, hit pause and try it by yourself before I give you the answer. And I'll usually pause after I post it so that you can hit pause. All right, real part. 8 plus 6, 14. Imaginary part. Negative 2I plus 5I is 3I. How do you subtract complex numbers? Let's say I have 7 minus 4I minus 2 minus 5I. See if you can try it on your own. Hit pause. Give it a try. For those of us who are still with me, or if you've just come back to join me, you subtract complex numbers the same way you add them. Real part to real part, imaginary part to imaginary part. Subtraction, you have to be a little more careful. So let's talk through this. I have the real part of 7 minus 2. 7 minus 2, 5. That wasn't so hard. Now the hard part. My complex part is a negative 4I. I'm going to write this one out. Minus a negative 5I. That becomes a negative 4I plus 5I, which equals 1I. With subtraction, you have to be careful with double negatives and so on. 2 minus, now plus 6i minus 4 minus 8i. 2 minus 4, real part minus real part is a negative 2. 6i minus a minus 8i is 6 plus 8, which is 14i. And get the hang of it? To add and subtract, real part to real part, imaginary part to imaginary part. Okay, that wasn't so bad. How about multiply? Let's take the same one we just had. 2 plus 6i times 4 minus 8i. I can view the I as I would any other variable when it comes to even addition, right? If this was 2 plus 6x minus 4 minus 8x, you do the like terms, right? It's kind of the same idea. I can treat the I basically like any other variable. Okay, so and I'm going to tweak that a little bit here in a second, so don't just stop my recording right now and run off and say, oh, it's just like any other variable. I'm going to tweak that here in just a second. Okay, so I'm going to treat it just like I would if that was an x. If I had 2 plus 6x times 4 minus 8x, how do I multiply two binomials? I FOIL, right? I multiply or I double distribute. I multiply this 2, wrong button. I multiply this 2 times 4. I multiply this 2 times 8i. That's not so bad. 2 times 4 is 8. I'm treating it like any other variable. 2 times 8i is 16i, just like it would be if it was 8x. Okay, then I go to the 6i times 4. And I'm going to the 6i times 8, negative 8i, gives me a negative 48i squared. Why is it I squared? Because I times I is I squared, just like x times x is x squared. Okay, think about what we just did above. How do we add and subtract complex numbers? We add and subtract like terms, real to real, imaginary to imaginary. Remember I said we treat it like any other variable, but I'm going to tweak that. Let's tweak it. Except for when I have an I squared. Because I squared means something, whereas x squared simply means x squared. But remember at the very beginning, what did I say I squared was? Or what did we discover I squared was? I squared is a negative 1. Right? So now I can come back down here, and I don't have to leave that I squared in there because I know what I squared is. I squared is a negative 1. Any other variable I can't say that about, but I can say I squared is a negative 1. So now this becomes a negative 48 times a negative 1, which is a positive 48. I squared is a negative 1. I take I squared out, I put negative 1 in its place because that's what I squared is. I multiply because this means multiply. I take a negative 48 times a negative 1 gives me a positive 48. Now let's combine like terms. Real to real, imaginary to imaginary. Positive 8, positive 48 is 56. Negative 16i, positive 24i is 8i. And we're done. Treat I like any other variable when you multiply, except for when you see an I squared, replace it with a negative 1. All right. Try this. No, sorry. Can change that. Okay, go. FOIL that thing out. 2 times 6 is 12. 2 times a negative 3i, negative 6i. Negative 4i. I'll draw my arrow so you can see what I'm doing. Negative 4i times a positive 6 is negative 24i. Negative 4i times a negative 3i is a positive 12i squared. Negative 4 times a negative 3 is a positive 12. I times I is I squared. I squared is a negative 1, so this becomes a negative 12. Combining like terms, I have positive 12 minus 12 is 0. No real part. Minus 30i. My answer, negative 30i. You could technically write 0 minus 30i. You just won't see it written like that. But that's not wrong. It's just not conventional. Okay? So this would be the preferred answer. Multiply I just like you would any other variable. When you see an I squared, replace it with a negative 1. All right, so if I squared has a special meaning, and we could go crazy on this. I'm not going to go too crazy on this. I'm just going to go through like a few of them. Does I cubed have a special meaning? Does I to the fourth, and so on. So let's go back to see it does. By definition, we said that, let me flip this around. We said that I equals the square root of a negative 1. And then we said, well, let's square both sides. And we got I squared equals a negative 1. So what about I cubed? Well, I cubed is the same thing as I squared times I, correct? That's how I can get I cubed, is multiply I squared and I. So technically, I cubed is a negative I, because this is a negative 1, and a negative 1 times I is a negative I. Or I could say, if I wanted, a negative square root of a negative 1, depending upon which one helps you simplify the most. But we could say that right there. So what is I to the fourth? I to the fourth. How do you get I to the fourth from what I already know? I'm going to stick with I squared, because I squared is a nice number. How do I get I to the fourth from I squared? Well, I squared times I squared would give me I to the fourth, right? Because I add exponents when I multiply like bases. Well, what is I squared? I squared is a negative 1. So it's a negative 1 times negative 1. That's interesting. I to the fourth is plain old 1. What is, and I'm not going to go too much more than this, what is I to the fifth? I to the fifth, from what I already know, is I to the fourth times I. Well, I to the fourth is just 1, so it's 1 times I, which is just I. So I to the fifth, we start over again, and I get I. What is I to the sixth? I to the sixth would be I to the fourth times I squared. Well, I to the fourth is just 1, so it's just 1 times I squared, which is just I squared. Which is what? Negative 1, right? So I know that I to the fifth is the same as I to the sixth is the same as I squared, I to the seventh then must be I to the third, and I to the fourth must, whoops, I got ahead of myself, I to the eighth must be I to the fourth, and the pattern just repeats itself over and over and over every 4 terms. And it's just kind of fun, so I got to throw one out there. I got to go a little crazy. What is I to the 19th? It repeats every 4, and on the 5th one, it starts over. So in that case, it repeats until it gets to I to the 16th, right? It'll repeat 4 times. I to the 4th, then I to the 8th, and then I to the 12th, and then I to the 16th, and it starts over with I to the 17th. So how far is it from I to the 16th to I to the 19th? Well, I to the 16th to I to the 19th is 3, is the power of 3, right? So it's the same thing as I cubed. What is I to the 75th? Sorry, I should have done that. Let's do a little easier. I to the 27th. Well, what multiple of 4 is right before 27? 24. So this is I to the 24th minus 27th minus I to the 24th, which is I to the 3rd. And so I to the 27th is the same thing as I to the 3rd. Every multiple of 4, it repeats on the 5th one. So you figure out how many times will 4 go into the 27 or the exponent, and then what's left over is your answer, your exponent. All right. Sorry, I got way sidetracked, but it's kind of fun to do that. And a lot of textbooks like to ask those kinds of questions, so it's kind of good to do that. All right, so I got addition, subtraction, multiplication. Let's do division. Excuse me. If you remember radicals, simplifying complex numbers is very similar to simplifying radicals. Dividing complex numbers is very similar to dividing radicals. So if I have 1 over, let's say 2 plus 3i, how do I divide? Remember that fancy name called the conjugate? I multiply top and bottom by the conjugate. What is the conjugate? It is the opposite of the imaginary part when written in standard complex number form. Take the middle sign, the sign in between them, and change it. If it was positive, make it negative. If it was negative, make it positive. Multiply both top and bottom by the same is multiplying by 1. Multiplying by 1 does not change the value of the number. I am doing a legitimate legal mathematical step. I am multiplying by 1. Multiplying by 1 does not change the value of what I start with. Okay, so I'm going to multiply both top and bottom by 2 minus 3i. Well, on top it's easy. It's 2 minus 3i. On bottom, I FOIL. 2 times 2 is 4. Minus 3 times a positive 2 is a negative 6i. Positive 6i minus 9i squared. Remember when we did conjugates back in the radical section? Those two go away. That's why we picked the conjugate. That's what a conjugate does. So these go away. Definition of I squared, or we obtained and we know I squared is negative 1. So this becomes plus 9. And 4 plus 9 is 13. And I get 2 minus 3i over 13. Most questions and most textbooks will ask you to write that in standard complex number form. Remember what that was? Oh, I think I erased it. I did erase it. Standard complex number form was the a plus bi. The real part, a, the imaginary part, bi. So let's somehow split this fraction into the two parts. Well, remember back from fractions, I can simply rewrite that as 2 over 13 minus 3i over 13. Because when you add fractions or subtract fractions, you add or subtract the top and you leave the 13 alone and just make it a 13. So if I have two numbers on top over a single common denominator, I could just split those up into the two fractions that we had before we put them together. All right, I'm really close. Let's just take that I and stick it off to the side. Why? Because now I know my A and I know my B, and there's my I. Standard complex number form. Your turn. Simplify into standard complex number form. All right, first step. I'm going to multiply top and bottom by 1 minus 3i. Top, I FOIL, right, because these are in parentheses. 4 times 1 is 4, minus 12i, plus 2i, minus 6i squared, over. On bottom, we've got 1 minus 3i, plus 3i, minus 9i squared. On top, I squared is a negative 1, so that becomes 6. and I get 10. Negative 12, positive 2 is a negative 10, I. On bottom, that goes away. Negative 9 times a negative 1 is a positive 9. 9 plus 1 is 10. Oh, this is going to be nice. 10 divided by 10 is 1. Negative 10 divided by negative 10 is a negative 1. And I get a nice, neat, complex number. That doesn't always happen. That was a nice one. All right. There is multiplying, dividing complex numbers, and simplifying complex numbers. All right. Give them a try.